Alright, so here's a question that's pretty challenging actually. On the surface it looks easy because you have this ant and the box, the rectangular prism that has to get from the space on the left, or the place on the left where the ant is, over to the place on the right where the honey is. On first glance when I looked at this question, I was like, well, this is pretty easy. If the ant just goes down an inch and then goes directly across, so it's another 30 inches, and then up another 11 inches to the honey, that's 1 plus 30 plus 11, which gets us 42 inches. Right, so as I'm looking at it, like, oh, okay, 42 inches, I'm done. Pretty easy, right? Because I think about this as a net, right? Like, if I have this being, the side where the ant is, right? Ant's right here. Ant. Okay. And then I have the bottom of the box. And then I have the other side where the honey is. Right. It doesn't really matter about the size of the box. I can draw those in if you want to, but it's not really going to change much. But here I can see that I can go from here, it would be 1 inch, plus another 30 inches to here, plus another 11 to over here. Right? So I end up with 1, 30, and then the 11 here. So I end up with that 42 inches. And originally I was like, oh, easy, problem's done. But remember, a net doesn't necessarily have to be the box being split up, or the shape being split up into these shapes. And I could add in the other sides here if you wanted to, where this is this, and then I have the very top of this thing. This is another way to draw this whole thing out, right? Looks a little confusing with it, all the numbers there, but that's essentially, if I roll that up, fold those along those lines, I end up with that prism there. So this is where thinking outside the box, quite literally here, gets you thinking about another way to imagine how else could you break this net down. And so take a look at this diagram here, and hopefully in class when we look at the actual diagrams or the physical boxes here, the nets of those, we can see what's happening. But take a look at this way that I've split this up here. Okay, and this is something I don't expect you to get off the top of your head, and I certainly didn't the first time I did it. But if you look at the same diagram, if I have the side over on the left where the ant is, and instead of putting the honey over on the directly across from on the right, I go ahead and fold it up, and you should see that I could still just kind of roll this thing up, and all the pieces should fold right on top of each other, and we should be good to go. But in this case right here, I can see that there's another path that I could go, like a direct path from the ant down to the honey, right? And it would be like a diagonal right there, rather than just going straight through and actually getting that set up, like we did before with the 42 inches here. So I can take a look at this thing and see that it's 32 inches from the ant, that's 1 inch, plus the bottom, which is 30, plus another 2 where the honey is, directly above it there. And then I can see that it is, and I've broken this down here, it's 6 inches from that spot directly across to the next crease, plus another 12, because those are 12 inches wide, plus another 6 inches. This is definitely not drawn to scale. I did a pretty bad job of my diagram here, but you get the idea here in that there's 32 inches, and then we have 24 inches for the height of this thing. And really this is a right triangle. So over here on the left-hand side, I have my Pythagorean theorem work for finding out what is that direct path. Remember, the shortest distance between 2 points is a line. And so in this case, drawing it as a net is a much easier way to see that line. So I end up with that 40 inches, which is definitely shorter than the other one that we had before. So if I'm looking at the diagram here, the ant is going to go along here. So directly from the 40, it'll go, it's hard to draw this, but off at an angle a bit, okay? And it's going to go all the way around and try to get to, actually, yeah, that's the right one. It's going to go across the side here. You'll see that it goes on the bottom, so I can draw this along the bottom a bit here, and then it's going to go and wrap up the side of it, right? And then it passes a little bit onto the top of it, right here, getting us to this point right here where it can go down. Now, it definitely doesn't look like a line there, but if you actually unfold it, you can see that it is a line. So really tough question, but it really gets at the idea that a net has powerful capabilities that we couldn't normally see if it's all together as a one rectangular prism, or even if we break it up in a different way. I hope this helps.